So the first thing that I want to talk about is what does it mean to solve an equation in general, and get a bit of a sense of why quadratic equations are a bit trickier. So what does it mean to solve any equation? It means, if you look at that first one, the linear equation, x equals 2x minus 12, what would it mean to solve that? It means find the value of x that balances the equation, where the left side would equal the right side. So let's say I just guess 10. What if x is 10? Well, then the left side, x is just 10. What's the right side? 2 times 10, which is 20, minus 12, which is 8. 10 does not equal 8, so 10 is not the right answer. Right? That's what solving an equation means. We're looking for the value of the variable that makes the equation true. Does that make sense? Hello, anybody? Yes? And a lot of people always ask this, a famous question in math class: why are we learning this? Why do I ever need to know this? And it's sometimes hard to see. Like when you're just solving equations, it's just a skill. It's hard to see. But for example, what if that equation represented your company's costs versus expenses, and you want to see when those things balance? How many products do I have to sell before those things balance? My costs and my expenses. And after that, I'll start making a profit. Or something along those lines, right? That would just be one example of where you might model a situation with mathematics. You're solving that equation, finding the value for x that when your expenditure is balanced, right? Your revenue is balanced. And then interpret your solution, interpret your answer. If you were an entrepreneur, if you were a private business owner, then you would do whatever you want with that information, help you make choices, something like that, right? So that's like a real world time where you might set up your own model and then solve it to figure out what x is. But in this case, x doesn't represent anything, so it's just a math question. It's just practice. At any rate, how would we solve this one? Oh, there we go. Well, we know how to solve these guys. They're pretty straightforward. So I would subtract 2x from both sides. And x minus 2x is negative x. And 2x minus 2x is 0. So those are gone. So I get x equals negative 12. And then whatever you think this looks like to you, there's lots of ways to think about it. Divide both sides by negative 1. Multiply both sides by negative 1. Or just flip the signs on both sides. And you end up with x equals positive 12. So again, x doesn't represent anything in here. So 12 is just the single number that balances that equation. 12 on one side, 2 times 12 minus 12 gives me 12 on the other side. Much better than guess and check, because I tried 10 and it didn't work. What am I going to try next? 11? Maybe then I try 9, try 8, try negative 14. Like you try a lot of numbers before you guessed the correct one, right? So guess and check's not a good way of solving equations. This is our way of solving linear equations. What is this called? This is called isolating. We're solving by isolating x. We can get all the x's to one side. If you remember, we did a day on this, like I think it was the first day of this course. We talked about solving equations, and I said letters equals numbers. Get the letters on one side, numbers on the other side. You're isolating x. Does that sound familiar? And that's a great way to solve linear equations. Here's a quadratic equation. It looks a little bit like what we were doing in the last unit, but it's got an equal sign in the middle, so it's not quite the same. It's not just a factoring question. It's an equation because there's a left side and the right side. They have to be balanced. What is this question asking? It's asking what number would it be true for that when you take the square, it's the same as multiplying the number by negative 7 and subtracting 12. Like what number would that be? Again, you could guess and check, but that would take a long time. This question, you might even be able to kind of solve by inspection. You might be able to kind of think, well, what kind of number doubled minus 12? But this question would be really hard to think of what number just by inspection to figure that out. And the problem is we can't isolate. What would happen? You don't have to write this down. You can if you really want. But if I tried to isolate, what would I do? Plus 7x plus 7x. So I would get x squared plus 7x. So I put all the x's on one side. But the problem is those aren't like terms. I can't add them together. right? I can't solve this by isolating. It actually is possible, but it's a hard way of doing it. It's not something that we're going to do right now. There's an easier way. Okay, so this is the problem, though. The reason why quadratics you can't isolate is because you have two different x terms, an x squared and an x. Whenever that's true, you can't solve it. It's like when we did linear systems, you have x and y. You can't just solve because you got two variables. It's very similar in this case. So we need to have a new way of solving quadratics that will allow us to figure out the value that makes them true. Yeah. But this isn't just anything squared. It's something squared plus something else. Right? Yeah, so you're exactly right.
But anything squared is a positive
Yep.
number, right? And then you would add 7 times that positive number.
No, but x squared. Okay, so the value of this, that's good thinking, but you know, what we're going to do is going to sidestep all those problems anyway, but if I did x squared, if x is negative 3 when I square it, I get positive 9, but x is still negative 3. So 9 plus 7 times, like, it could still work out, right? Actually, negative 3 is one of the answers, I think. So there you go. Okay, so you want to write this down. In order to solve quadratics, we need to know something about this. It's called the zero product property. So consider this. We have some unknown A and another unknown B. Okay, we don't know what they are. They're variables, capital A, capital B for some reason this time. But just like X. And you multiply them together and you get 0. So their product, the product of A and B, A times B, that's what product means, right? Is 0. So what can we deduce? What can we use? Like, you can use logic to figure something out here about A and or B. If their product is 0, what do we know about them?
At least one of them is 0.
One of them has to be 0. Come up with two numbers that are both not 0, that when you multiply them together gives you 0. Somebody do that right now. Anybody come up with two numbers that you multiply together where one of them isn't 0, but it equals 0? Some people say, well, what about 5 and negative 5? Well, if you add them, that's 0, but if you multiply them, that's negative 25. That's not 0. So opposite signs will not work here. There's nothing, right? That's not a real challenge. There's no two numbers that you multiply together to give you 0. If the product is 0, one of those numbers has to be 0. So either A equals 0 or B equals 0. Okay? And this is true for any two things or any number of things if you multiply them together. Right? That one of them has to be 0. So any two things multiplied together, this is my A, this is my B, multiply them, one of them has to be 0. Does that make sense? Zero product property. So either whatever's inside those brackets would have to equal 0, or whatever's inside those brackets has to equal 0. This is a really important part of how we do it. Now, once we start solving, a lot of you are going to forget about this because you're not worried about why, you're just going to do it. But understanding why will really help under some situations. And a lot of people actually struggle with math because they don't understand why and they don't bother asking why or trying to figure out why. And sometimes the why is hard. So teachers don't even always talk about the why. But in this case, here's why this works. And I think this is important to know. So try to keep this in mind today while you're working, tomorrow while you're working. Zero product property is what allows this to work. It's an important property. Now, again, you don't have to write this down, but another thing to note, for future, it won't really be a big deal today, but down the road it will. There is no such thing as the 8 product property. This always makes me laugh. I use the number 8 because the student used it a number of years ago. They tried to use the 8 product property to solve a question. So it was something like this. A times B equals 8. So either A equals 8 or B equals 8. No. The 0 product property, it only works for 0. How could it work for something else? If 2 numbers multiply to 8, one of them is 8? No. What about 2 times 4? Like, it doesn't work for anything except for 0. It's the magic of 0. 0 is one of these magic, it's like 1, right? Sometimes we use 1 in a magic way in math class. 0 is this magic number that has special properties, and we can take advantage of them. Like when we added 0 in a convenient way when we were completing the square. Same idea, right? There's no such thing as the 8 product property or 9 product property or anything like that. It has to equal 0 because of the 0 product property. Okay, so one last thing to remember, you don't have to write this down. What we learned in the last unit, factoring is the process of taking something that is not a product, this plus this plus this, and turning it into a product. And if everything is a product, I can use the 0 product property. When I say everything is a product, I mean everything. It can't be like A times B plus C equals 0. There's no product property there. That does not make sense. So everything on one side has to be a product. The other side is 0. And then we use the 0 product property. It's a really simple to use the 0 product property. Like you don't even really, this is what I'm saying, you won't even really think about that you're using it. You should, but you just kind of do it. Any questions before we move on? Start doing some of these? You sure? Okay, so here we go. What do I have here? I have something that looks like it's already been factored. I'm not expanding it. I'm trying to solve this. I want it in this factored form to solve. So in other words, that's my A, that's my B. There's nothing else going on. If 2 things multiply to 0, one or the other has to be 0. Therefore, x plus 6 equals 0, or, I don't actually have to write or, x minus 3 equals 0. One or the other. Or both, but it won't be both at the same time, obviously. Yes? No.
Don't both x's have to be 0 for this?
No. 0 times 10 is 0.
I know, but isn't it like x times 3? No.
No. So this is where I've used my 0 product property to say either the first bracket or the second bracket is 0. Now I have 2 simple little linear solutions solved. So either x equals negative 6 or x equals positive 3. And that's it. Okay, let's try another one. We won't really get questions like this in grade 10, but just for our understanding, I think it's a little bit important to see. So if this is my A, this is my B, now I have a C, that's fine. Everything is multiplied. So what do I know? I know one of those 3 things has to equal 0. So therefore, 2x plus 5 equals 0, x minus 1 equals 0, or x minus 4 equals 0. One of those 3 things has to be equal to 0. So there's no rule that there's 2 solutions. We kind of glossed over that, but take a look. There's 2 different solutions. What does that mean? Like in linear equations, there was only ever one. X equals 12. X equals negative 2. That's the solution. In this case, I have 2. How can you have 2? 2 numbers balance that equation. We'll look at that a little bit more later, but 2 numbers balance that equation. So there's 2 possible solutions. In this case, there's going to be 3 possible solutions. This one's easy, x equals 1. This one's easy, x equals 4. This one's a little bit trickier. Subtract 5 from both sides. So 2x equals negative 5. And then divide both sides by 2. And x equals negative 5 over 2. 3 possible values of x will make that first equation be true. Just put your pencils down for a minute once you get that copied. Just watch. If I use this one, this bracket will be 0, and these two won't, but the whole thing will be 0, because it's 0 times something times something. That one's harder to see, the fraction. If I use this one, and I sub it in here, that's going to give me 0. 1 minus 1 is 0, so that's going to be 0. So it doesn't matter what that bracket or that bracket is. It's 0 times something, which is 0. And then same thing for 4. When I put 4 in there, that bracket's 0. These two won't be, but the whole thing is 0. It's not like I put this one into that bracket, this one into that bracket, this one into that bracket. No. It's one solution for the whole equation, right? But there's 3 different ones that will solve the whole equation. Okay, let's do one where we have to actually factor. Solve each quadratic equation by factoring. So this is where all those skills, like all that factoring work that we did, is going to come into play, because all of these are going to be different. So what's this? It's a simple trinomial. So that's an easy one. Is everybody ready? You got this copied down? We'll go ahead and factor it. No equal signs now, right? We don't do equal signs on the left side. It's an equation, so the equal sign goes in the middle somewhere. So I'm just going to factor this left side. 2 numbers that add to 10, multiply to 10 and add to 3, what are they? It's a race, quick. Who can get there first? 2 and 5. What kind of 2? What kind of 5? Negative 5, positive 2. Nice. Everybody okay with that so far? This is not done. It's factored, but we have to solve it. Therefore, x minus 5 equals 0, and x plus 2 equals 0. X equals 5, x equals negative 2. If you're good at factoring, this is like sort of 2 extra steps, that's it. All that work for factoring is when that pays off. If you're good at factoring, this is easy. If you're not great at factoring, well, you got more practice. Okay, what kind of question is B? It is a complex trinomial. Very good. So let's go ahead and factor that. Don't forget the equal 0. It's an equation, so you do need it on every step. Or if it's equal to something else. Make sure you don't just leave off half the equation. So I think this works out to plus 3 and minus 5. So I've got positive 9x minus 5x, which gives me positive 4x. Okay, so I just factored. I made sure that the right side was 0. Therefore, 3x minus 5 equals 0, or x plus 3 equals 0. Again, this one's easy. X equals negative 3. How do I do this? The one on the left. Move the 5 over. Divide by 3. So far, so good. Any questions? All right, we'll keep going. So anything goes with these factoring questions, just like on the test. All the factoring, What do we always do? Yes, kept for a common factor first. I love it. So obviously there's a common factor here. X squared minus 16 equals 0, yes? And x squared minus 16 is? That's it? Yeah. What's it actually called? Not that one. Not quite. Difference of squares, right? This is the difference of squares. Very good. So 2, and what is it? So it's just x plus 4, x minus 4 equals 0. So I've got 3 things here, but 2 can't equal 0. Don't say therefore 2 equals 0, or no, 2 can't equal, like that's part of the product, but no, 2 can't equal 0. So it's just therefore x plus 4 is 0, and x minus 4 is 0. So x equals negative 4, x equals positive 4. Is that good? Don't write this down, but I'm going to show you something. We'll talk about it more tomorrow, so put your pencil down and just watch. From this step, I could have done this. So I got 2x squared minus 16 equals 0. Now, you can only do this if you know what you're doing. Okay? This is like if you're playing with, this is like, don't try this at home, right? We're trained experts. So this is different from the last unit in that it's an equation, and before those were just expressions. It was just factor. Now this is an equation. That means I can do some things differently. I can divide both sides by 2. And what is 0 divided by 2? Please don't say 2. It's still 0. And 2 divided by 2 is 1, so I get x squared minus 16 equals 0. In the last unit, when you pull out the common factor, you have to keep writing it. In this unit, I can technically divide both sides by 2, and the 2 is gone. But here's the problem. This is why I say don't write this down and be careful. Some people start going, oh, this is great. I can just get rid of stuff. I'll get rid of that 4. I'll get rid of that 10. Oh, I don't like that x. I'll get rid of that x. They just start dividing both sides by everything and getting rid of all kinds of stuff. You got to know when you can do this and when you can't. So not everything that we do for the rest of the year is an equation. You can't always do this. You can always leave the 2 and just leave it there. That'll never be wrong. Sometimes when you divide by 2, you're gonna do it at the wrong time and your answer is gonna be wrong. So if you don't know when, don't do it at all. But if you get it and you picture it and this stuff makes sense, then you can get rid of common factors in a case like this. Okay, good. Next one. Okay, so 2 more examples. What's going on with this one? Some people think, oh, I'll divide both sides by x and get rid of the x's and then I can do... No, you're never allowed to do that. That's not how this works. What do you think we do in this case? Megan. I can common factor, but I'm not going to do that yet. I could move the 3 over. We're actually going to move the 12, though. So we're going to move everything to one side. So I'm going to do minus 12x and minus 12x. So in other words, 3x squared minus 12x equals 0. I want to have one side equal to 0. You could have divided both sides by 3, and once you get rolling with this, if you want to do that, that'd be fine. But I'm going to keep it simple for now and not do that. It's funny, this is one of the questions that's actually the easiest question. That's a really hard question for some people, and they get it wrong every time. They don't know how to solve these questions. For some reason, they get really good at the trinomials, really good at spotting difference of squares, and for some reason, even though this one is actually the easiest, some people just, it never clicks for them. They always just forget how to do it, even though it's really easy. Liam. That's right. Now we common factor out the 3x. we don't just get x equals 4. We get 3x times x minus 4 equals 0. So I could divide by the 3 and get rid of the 3, but I'm not going to bother. I don't need to. I've got two things. Either one or the other has to be 0. So therefore, 3x equals 0 or x minus 4 equals 0. If 3x is 0, divide both sides by 3. Please don't say x equals 3, x equals 0. And in this case, x equals 4. So these, I'm going to go back over, there's sort of 3 types that we covered here. Sort of 4, I guess, in a way, but really more 3. I'm going to go back over it in a minute, okay, and help you try to figure out when you do this type, because look how easy it is. Common factor is so easy. You can watch if you want. You don't have to write this down. I'm going to do a left side, right side check, and I think this might help paint a clearer picture for somebody. So I'm going to check x equals 0. Left side equals 3x squared. Right side equals 12x. These are 2 separate answers. It's not like 0 is part of it and 4 is the other. Some people think, so I'll sub 0 into this and 4 into that. No, that's not how this works. Okay, so I'm checking x equals 0. 3 times 0 squared and 12 times 0. So that's 0, and that's also 0. Left side, it was a fluke that it worked out 0. Left side equals right side. Therefore, x equals 0 is true. Now I'm going to check x equals 4. So you would have to do them separately. Left side equals 3x squared. Right side equals 12x, which is 12 times 4, 48. 3 times 4 squared, 3 times 16, also 48. Left side equals right side, therefore x equals 4. See how this works? 2 separate solutions. Individually, they're answers to the question. Not like both of them combined. Okay, so just watch for a minute. I want to show you something. Take a look. Think about it like this. This is my basic form, ax squared plus bx plus c equals 0. Everything is simplified. I've moved everything to one side. If I have all 3 terms, it's either this one or this one, a simple or complex trinomial. So you're factoring that way, and your solution is going to look like one of these 2 things. What happens if my b is gone, so b equals 0, I would have just ax squared plus or minus c equals 0. That's this kind, right? No middle term. Difference of squares. What happens if I have ax squared plus bx equals 0? No c term. Common factor. So what I would do is I would try to think about the trinomial, and do I have all 3 terms, or am I missing the middle term or missing the last term? And when you're missing the last term, it's common factor. People forget how to do those ones, so that's maybe a tip that could help. Okay, we're going to do one more. Any questions before we get started? A little bit of extra work for this one. What do we have to do first? Zakira? Move everything to one side. Very good. So I want you to do that. I want you to move everything to the left. So go ahead and try. Did you get 6x squared plus 17x plus 7 equals 0? If you went the other direction and you have negative 6x squared, it's way harder. We didn't do any factoring with a negative x squared term. It's way harder. So you would flip all the signs, but if you can avoid it and just make sure everything stays positive, then do that. Doesn't matter if it's on the left or the right, but you want the x squared coefficient to be positive. Do not factor, don't try to factor when the x squared coefficient is negative. Bad idea. All the practice, all the patterns you've built in your brain to understand this stuff are when x squared is positive. So none of that will work if it's negative. Okay, so just like use that to your advantage. Okay, go ahead and try to factor that. I'm going to give you a minute. And then don't forget the extra step.